All right, guys, this is a review for Unit 1 test. First question, determine the probability of randomly selecting a data value between the mean and two standard deviations below. So remember that tomorrow you're going to have your, let me move that to the side. You're going to have your formula sheet given to you. Okay, you're going to have a formula sheet given to you. So look at the formula and their percentages. So remember, this is 34, this is 34, this is going to be 13.5, this is going to be 2.35, and this is going to be 0.15 on the bottom, and the same reflects on this side. Okay, see, it's hard to write, so small, 0.15. Now it's asking you for two standard deviations between the mean. Remember, the mean is your middle right here. Okay, and two standard deviations below. So below the mean are these two boxes right here. These are two standard deviations below. All you have to do is add 13 and 34 together. So 34 plus 13.5. So the both probability percentages, you are going to get 47.5%. Okay. Now for the next question, again, it is asking you to find a probability of random selecting data between the mean. So again, the mean right here and one standard deviation above. So this box right here. Okay. So remember that this was 34%. Okay. So 34 is your answer. All right. That's all it's asking you. Okay, so above, you're going to count the standard deviation boxes, or below, and you're going to just add the percentages together. You do not subtract anything from each other. You're just trying to figure out what is the probability area underneath that curve, okay? All right, so the electricity usage of a certain brand of a dishwasher during a standard cycle is normally distributed. The dishwasher have a mean in electricity of, so the mean is 1.5, and a standard deviation will be 0.25, okay? So again, when you are creating this is your mean right here in the middle, so that's where we start with our mean, which is our average of 1.5, and then we're going to add to the right 0.25, so that's going to be 1.75. The next one is 2, and the next one is going to be 2.25, okay? Then we're going to subtract to the left of 1.5 minus 0.25, that is going to be 1.25, okay? 1 and 0.75, okay? Now, the first question says, use the mean and standard deviations to label and include 3 standard deviations above the mean. So again, 3 standard deviations above the mean means 3 boxes, 1, 2, 3 to the right. 3 standard deviations above the mean and below the mean, so both 3 above and below, right? So then 1, 2, 3 below. So remember that 3 standard deviations above and 3 standard deviations below, that is going to be 99.7, because again, we are going to add all these percentages together. So 34, 34, 13.5, 13.5, and then 2 of 2.35, okay? So we're adding all these percentages, is going to give us 99.7. Also remember that we got 3 percentages, 68, 95, and 99.7. This is first number, second number, third number. That means 1 standard deviation to the right or to the left, 2 standard deviations to the right, to the left, and 3 standard deviations to the right, to the left of the mean, okay? So 99.7. All right, the next one says, determine the percentage of the dishwasher with electricity usage, 2 standard deviations above the mean and 2 standard deviations below the mean. So again, 2 to the right and 2 to the left. And of course, 2 to the right and to the left of the middle, it's 95%. And if you don't know that, you can just add these percentages together. 34 and 34 and 13.5 and 13.5 will give you 95, okay? And then number 5 talks about determine the percentage of the dishwasher of electricity between these two kilowatts. So that's 1.25 and 1.75. So 1.25 1.25 it's right here, and 1.75 it's right here. So from here to here, we got 68%. Okay, so again, you add 34 plus 34, that's 68%. Okay. All right, question 6, it says, the exercise times of the people at the local gym are normally distributed with a mean of 45 and a standard deviation of 15. Determine the z-scores multiple for 30 minutes and 75 minutes, okay? So we're going to do both. So we have a z-score, again, formula, it's on the formula sheet, x minus the mean divided by standard deviation. So we got 30 minus the mean, which is 45, divided by standard deviation, which is 15. And that's going to give us -1. And we got the second one, which is 75 minutes minus the standard deviation, minus the mean, which is our average, which is 45 minutes, divided by standard deviation, which is 15. And that is 2. Okay. Now, how do we interpret it? 30 is 1 standard deviation below the mean, and 75 is 2 standard deviations above the mean, because our z-score said -1. So here I'm going to explain you guys something, okay? Here is the mean, and you guys learned that the z-score, the mean for the z-score is always 0. We learned that on the first, on the beginning of that chapter, okay? Now you have 1, 2, and 3 standard deviations above, and 1, and 2, and 3 standard deviations below. Okay, this is a z-score table, okay? Now we are saying that according to this number and this number right here, we are saying that 30 minutes, it's 1 standard deviations below, because negative z-score means we're going 1 standard deviations below, okay? The mean, okay? This is your mean right here, all right? So we are right here. 2, it's 2 standard deviations above the mean. So 1, 2, we are right here, okay? So that's all. 75 just means it's 2 standard deviations above the mean, means above the average. And -1 means 30 is below the average, okay? All right. Now, looking at the next question, the average of the high temperature in the summer in Phoenix, it's 105 degrees, okay? Let me delete that as well, unless you guys want to pause that to save that, okay? So we can read it better. So mean is 105 degrees, that's my average, and the standard deviation is 2.3 degrees. Now, assuming the temperature are normally distributed, what is the z-score for a day with a high temperatures of 100 degrees? So 100 is our x, okay? So I'm going to calculate it. So it's going to be 100 minus our average, which is 105 divided by 2.3. You are going to get -2.17. Now, answer A and answer D, answer A and answer C are out. Now you're between answer B, no, I'm sorry, answer C, it's out. Answer A and answer C, it's out, because it's positive z-score, and we got negative, okay? Now we got negative B, it says -2.17. The high temperature that day, it's 2.17 standard deviations below. Or is it -2.17, the high temperatures that day is just 0.17 standard deviations above. So again, I'm going to do that graph, okay? We got a negative answer, okay? Which means if I draw the graph, I got 0, 1, 2, 3, 1, 2, 3, okay? We are -2.7. That means we are below the mean 1, 2, and some, 0.17. We are right here, okay? So we are 2.17 points below the mean. Okay, we're not above the average, we are below the average. The temperature is less than average, okay? All right, Harry scored 55 in the English test, which mean should we mean here? With the mean, that's what it's supposed to say. With the mean was 50, and a standard deviation 6, okay? So he scored 64 in a mathematics test with the mean of 59, standard deviation 9. So we are going to create 2 z-scores. We got the English z-score, okay? So this is going to be our mean of 50, and our score of 55, okay? Minus the mean, which is our average, and divided by standard deviation of 6. All right, and we are going to get 0.0 83. All right. Now for mathematics, okay, we have a score of 64 minus the average, this is 4, minus the average, which is 59, and all of this is divided by standard deviation of 9, and you guys going to get 56. Of course, from z-scores, you can say that he scored better on English, okay? Now, question 9 relates to question 8. It says, what mark would have had to score? What mark would Henry have to score in mathematics? So what score does he needs to get in math for his performance to be equivalent to the English? So again, we are going to take the z-score of the English score because we want to use the z-score to level out those 2 exams. Okay, so we're going to use the z-score for English, and then we are going to solve for x because we don't know what we need him to score to be on the same level as English. Okay, but now we're going to subtract the average for history. Oh, mathematics. I'm sorry. We're going to use the math mean and standard deviation because we're trying to figure it out. What is he going to score in math, right? Like what does he needs to score in math to be on the same level as English? So we're going to use the z-score for English, but we're going to use the average for math, which is 59, and then standard deviation for math as well. Now, this is just simple math. To get rid of that fraction, we're going to multiply it by what's on the bottom of this fraction. So whatever it's here, you're going to multiply it to the right, and you got to do the same thing on the left side as well. X minus 59 is going to drop down. Here on the right side, you're going to multiply this out, and you are going to get 7.47. And of course, the last thing is to add 59 to it. Okay, so now X will equal 66.2. That means that he has to score 66.2%. He has to get 66.2 on the exam to be equivalent to his English exam with the same z-score. Okay. Again, moving forward, question 10. So set of the data has a normally distributed with a mean of 5.1 and a standard deviation of 0.9. Now you need to figure it out. What will it be? Now you can see if it's going to add up using a bell curve and start with the mean, or you can use your calculator. So we're going to have a 5.1. We're going to add 0.9, so this is going to be 6. We're going to add, this is going to be 6.9, and we're going to add, and this is going to be 6.9, 7.8. Okay. Now all we need is between these 2 points. So 6.0 and 7 and 6.9 is right here. And again, according to your percentages on your formula sheet, you're going to be able to say that this is 34 and this is 13.5. Okay. So that is your answer right here, answer C. Okay. You can also use a calculator to check that answer. Again, if you do use a calculator, let me show you how to do that. All right, so we're going to go again to function, normal distribution. You're going to figure out and put your mean of 5.1, comma, and 2. Nope, it was 0.9. It's your standard deviation, and right here, you're going to go between these 2 points. So we had the points of 6.0 and 6.9. Okay, and again, right here, it's 0.13.59. That's around 13.6%, which again, you can eliminate some of those answers right here and figure out that it would be C, regardless, okay? Now, 68%, it says number 12, 68% of data falls between what 2 values? Again, we do have to subtract on the other side, 5.1, and take 0.9 away. So this is going to be 4.2 right here. So 68% are those two boxes right here. So that's between 4.2 and 6.0. Okay, so again, 68%, remember, is 34 and 34. It's one standard deviation on each side of the middle, right? So one box on each side. So that's going to be answer A. All right, question 13, it says, what is the probability the data value is at most 4? So I can already tell that 4, it's not going to be right here. So what I'm going to do is I'm going to go to my Desmos. All right, and at most, I look at most, the word at most as your maximum, okay? At most means a lot, means maximum. So that means I'm going to put 4 as my maximum, okay? Because it says at most 4. So your percentage is 0.11. And this is going to be an answer A, okay? Now the next one, it says, what is a z-score corresponds to a data value of 7? Again, data value. A lot of my students were confused in putting that as your z. This is not your z. You are asked, what is a z-score? You are solving for z, okay? 7 is your data value. That's your x. So we're going to do 7 minus 5.1, which was your, right here, which is your mean and standard deviation right here. If you want to look back to the original question. Okay, 5.1 and 0.9. So divided by 0.9, and you should get answer 2.11. Okay, so it would be answer B. All right, scores on the midterm were normally distributed with the mean of 65 and standard deviation of 8. Use empirical rule. Empirical rule means that bell curve, okay? Find each probability. So you have a 65 right here, and you're going to have 1, 2, 3, 1, 2, 3. So we're going to add and subtract 8. So this is going to be 73. This is going to be 81, and this is going to be 89. Okay. Now on the way back, we're going to subtract it. This is going to be 57. This is going to be 49, and this is going to be 41. Now it's asking you less than or equal to 73. So where is my 73? It's right here, less than or equal to. Again, it's going to go in this direction, okay? Less than or equal to means to the left. So you're going to add all these percentages together. 13.5, 2.35. And again, you can also use a calculator, Desmos, to make sure you check your answer and making 73 a maximum, okay? This will be your max. And you can compare the answers, okay? So this is going to be 0.15. So here, if you add all these percentages, you're going to get 84%. Okay. Now question 16 says greater than or equal to 81. So greater than or equal to 81. 81 is right here. So that means we're going in this direction. So here, it should be 13.5, 2.35, and 0.15. So again, what am I adding? I'm adding these two, okay? So this is going to be 25%. 0.2, it's going to be 2 let me see. You adding, it's going to be greater than or equal to 81. So it's going to be 2.35 plus 1.5. So it's going to be 2.5%. Okay, so you're just adding these two together. Between 57 and 73, 57 and 73. So again, these two percentages, so that means 68%. And lastly, 99.7 data falls between what two scores? Again, 99.7, it's third number. So that means 3 standard deviations to the left and 3 standard deviations to the right, okay? So that means we having, this is your middle, we have 1, 2, 3, 1, 2, 3, okay? So it's going to be between 41 and 89. Okay, so you go all this across. So 3 standard deviations, remember, 1, 2, 3, 3 standard deviations to each side of your average, okay? So the answer for number 18 is between 41 and 89, okay? So 41 and 89, between these 2 points right here, it's 99.7% of data, all right? So between this point and this point right here, okay?